Okay, boys and girls, welcome. Today, I would like to give you the last session of chapter 10, which is called the relations among angles, arcs, and chords. But actually, I would like to focus on the parts of angles because, actually, the chapter 10.4 tells you a fact that I've mentioned in the last clip when we talked about the chapter 10.3. And in this clip, we want to investigate more, so we take a look. So first of all, for the part A, the equal relation. So what's an equal relation? So you can see, the book, will tell you the following is that, when we talk about the equal relation, so you can see that the equal relation is just easy. Is that if the angles, subtend towards the same center. For example, you can see in this figure x and y, if they're the same, then we will have the arc the same, or vice versa. That means that if the arc the same, is angle the same. But actually, you understand this one is the fact that we said before. Is that because when we talk about the arc of the angle, actually we can think about they are the same thing. They are the same thing actually. So because they are just like the same thing, that means that if the angle is the same, so you should have the corresponding the arc the same. So we will say in the reason we call equal angles equal arcs. But once again, as I mentioned in the last clip, you don't need to write the words equal angles equal arcs in your step. So you can just state the fact that if you have two angles the same, so the arc the same, or vice versa. But actually, you can see the equal relation can extend more to say the chord. What's the meaning of chord? That means that the vertical line, the straight lines, the straight line segment between the 2 points. For example, this time if I say the angles the same, then we will have the chord also the same. So similarly, when we say the chord and arc, we will also have the relation. But actually, you understand that the equal relation actually comes from a very important fact, is that when we consider a circle, and then you consider 4 points on the circle. For example, we say A, B, and C, D here. So you can see from O, you draw the line going to A, B, and C, and D are all the radar of the circle. So you can see these 4 lengths are the same. So if I want to say the equal relation, just means that if you have one more condition. For example, if I say the angle AOB, which are this one, and angle COD are the same. So if they're the same, so you satisfy the condition of SAS, because you should have OA and OB are the two sizes, and the angle AOB is the angle included in these two sizes. So you satisfy the condition of SAS. If this time I'm not saying the angles equal, but we say the chords equal. For example, this time I say the AB chord, this horizontal line, this straight line to say, and then this straight line CD. I think I should draw it better. I draw two more strokes here. Yeah. For example, this time I say CD here. So we will say that now, if you have the two chords are the same, then you can see that it satisfies the condition of SSS, because all the sizes will become the same here. So because all the things are the same, so you can see these two triangles are congruent triangle due to the reason of SSS or SAS, and the congruent triangle would be triangle AOB and congruent to the triangle COD. So because of this, then you can also imply the next thing are equal. For example, the cos equal, so the angles equal, and the cos equal. So this is actually the equal relation. And also, if you still remember what I said before, we'll say that for any angle, at the center, it should corresponding to the arcs, subtended to it. For example, CD. So you can also see that angles equal will also imply the arc equal. So this is equal relation. Very easy to understand. And the last thing, we will talk about the equal relation. So we will go to the last one, is called the proportional relation. So as I mentioned in the last clip, we say when we talk about an angle, actually in other countries such as UK or US, some of the textbook in UK and US just say just use the degree measure to say the length of the arc. So because actually we will say how large is an angle is identically equal to we talk about how long is the arc. Because if you still remember what I mentioned in the previous clip in the online lesson, so I'll just give you to see once again this important thing. Also wait a moment. Yeah, here this one. Yeah, Yeah. So this one. Yes, no, it should be, yeah, this one here. So you can see that, okay, the relation between the angles and the arc actually are corresponding to each other, because when we say the angles larger, it should be corresponding to the arcs larger, because the angle actually also can be represented by the lengths of the arc, okay, to the angle itself. Okay, so you can easily see that if I say, okay, the the relation between the angles and the arc, okay, the angles and the arc, actually we will also have the proportional relation. It means that if the angles are in the ratio, so they also as the arc length. Okay, so you can see the theorem 13 just tells you the fact is that if the angle is in the ratio mn, so the arc length should also be in the ratio mn, because actually angles and arc are identical. So we can just say the proportional relation, and you can see the both would use the sentence to say as proportional to angle center, but actually once again you don't need to write here. So vice versa is the same. But okay, before I give you some examples, so I think the example is very easy, you can just read by yourself. But do remember is that when we look at the example, so do remember is that notice carefully, okay, what you can have. For example, in this question, now you have to find the angle AOC, which is this angle, but you are not given any angle, okay, from AC and also as BC, because they are both known. So you can use the relation is that now AC and ACR. So this I should write it once again here. Yeah, so this one AC arc and BCR, or we say the CBR, now is given to be 10 to 12. It means that now we can also write the angles of standard from these two arcs. For example, AOC and also the angle BOC should have the same ratio 10 to 12. So because you have the ratio, so what we need to do is that you can write this one as 10K, and also this one you can write as 12K, okay, the 12K. So you can write the relation is that 10K at 12K at 140 degrees equals to 360 simply by angles and point. So you can also get from this relation to get K is 10, so you can imply that the angle AOC is just 10, okay, times, okay, 10 degrees, because we will say the K is 10 degrees, so you have 100 degrees, okay, for this question. So actually, okay, you can see for doing this question, it's just as easy this way. So the book will not use the book K method, but the book will actually to compare the angles themselves. It's also okay to get the similar result here. But do remember, I just want to remind you a very important thing is that the arcs, okay, are in ratio, so the angles are in the ratio, vice versa. Okay. But do remember is that, okay, when we do such questions, okay, sometimes you have to draw the line. So this one you may read by yourself. But here, I would like to give you one more reminder is that, now, if this time for a circle, okay, now, when we want to compare, okay, the different angle, what's the different angle? For example, one angle is at the center. So I think that I should draw it better. Sorry. I should draw better lines to let you see. Yeah, for example, this one. Now, this is the angle at center. And then now, I may compare with the other angle, okay, which is at the circumference, for example, this. Okay, you have the different point here. For example, this time, I say that now, I have this one, okay, is in the ratio of m, and this one is the ratio of n. But you can easily see that these two angles, one is at the center and one is at the circumference. So you cannot just directly compare. For example, if I say this angle, I give you the name. For example, I say this one is x and this one is y. So don't just think that, oh, Mr. Wong, can I just say x to y equals to m to n? No, because you have to understand that because they are not, okay, pointing towards the same point. We cannot just say they are in proportion in this way, because when we say the proportion, you should have the same point here. But you really understand that now if I say we draw another line here, for example, we say this one, okay, here, then you will know that this one should be 2y. Why? Because you can see they are coming from the same arc, this one, and one is towards the circle, one is towards center, so you have the twice relation, so we can see this one is 2. But actually, you can easily see it now, if I have such a things that you can compare, then I can say this time x to 2y is equal to m to n. That means that this time we can really write in this way, because you can see that x and 2y are both at the center, so we can compare. And then we can use the ratio of the arc to say the ratio of the angles are also m to n. Then you have the relation. So actually this one will give you the things that if I say x to y, it becomes 2m to n, because you have to multiply 2, okay, on both 2y and n here. So you divided 2, you multiply the 2 on x and m, you get, okay, 2 and 2 cancel, you have the m here. Okay, so actually you have such a result. That means that if you really want to compare the angle at center and angle circumference, is okay. But do remember is that multiply the angle at center by 2, because you can actually say angle at center, it should be 2 here. Or you may also say that, oh, Mr. Wong, can we just compare not angle at center or angle circle, but just we compare the angle as circumference or the circle together, is also okay. Because you can use this that if they are both, okay, comparing the angle at circumference, okay, angle at circumference, actually you will have the half of the angle at center, so just over 2 on both angles, so we have to keep the same ratio. So do remember is that for this situation, this scenario, okay, do remember that even, okay, the circle, okay, we have different arc pointing towards different parts of the circle. For example, one is here, one is here. So the most important thing is that you have to understand if I have the ratio of this one is m to n, also this one. So you have to also understand here that even this one is x to y, we have the same thing, which is m to n equals to x to y. It means that the two angles may not need to share the same side here, because you can see 3 and 14 they share the same side BP. But actually you don't need to say they are sharing the same side, because the most important thing is where is your arc, how long is your arc. So it will becomes, okay, corresponding to the how large is the angle. So please get this very important idea, is say how large is an angle, is how long is the arc. Okay, so this is the end of this session. Very easy. Okay, so I'll give you the classwork first. So the classwork would be this 7 questions. Very easy, because I prepared the summary homework to give you next week. So please keep, okay, hard working this week, because instead of this homework you may need to do all the past homework you haven't done before. And do remember is that I will count all your marks in your previous homeworks as your daily mark. So we will also announce to you later how should mathematics department will count your mathematics daily mark, okay, for Form 4. Okay, so please remember. But please do these 7 questions first. And now I would like to go back to talk about Chapter 10.3. One thing I haven't mentioned, okay, in my previous clip, to talk about more about the relation between angle and the arc. So if you still remember, okay, last lesson, okay, we did very hurry, because we have not enough time here. But here I would like to give you a notes for some students, so for especially for those who are studying M2, because these 4 figures are very special figures for you to understand, to learn more about the angle and also the arc. So if you still remember, for M2 student, you have learned something is called the radian measure. Radian measure is actually talking about the largest of the angle and the relation of the arc. Okay, if you still remember when we talk about radian, okay, when we talk about radian, R-A-D-I-A-N, radian, it means that if you have a unit circle, that means that the circle with the radius 1 unit. Then we will say that if the radius 1 circle, we say the unit circle with an arc also equals to 1 unit also, then we will say that this angle theta, we will define this angle should have the same side as the arc. So we will say the theta is called 1 in units, and no unit here, or you can simply to say 1 radian. But actually in mathematics we will simply to say theta is 1, okay, because actually radian measure just tell us the fact, as I mentioned, is that the angle size and the arc length are corresponding to each other, so we can say they're the same. For example, if the arc is 1 in length, so the angle is in 1 in size, so we call the radian. So because of this, then actually you can see that for the unit circle, so you can see all the circle how I'm writing the unit circle here, so we have the same the following result. For example, for a unit circle, we should have the theta equals to x radian. Okay, if I say it is unit circle, for example, we say if I say this one is 1 and 1 here, so if you have the arc length is x, so we will say the angle should have the size x also. And the second one is that if this time the arc length x corresponding to the angle at circumference, you have to half of the measure of the arc length, because angle at circumference is half of the angle at center. And when we define the angle at center is the same as the arc length, so we have 1/2x here. And also these two are very special. So even for core student, okay, you may investigate why these two figure works. Is that so this time you can see the angle we consider is not angle at center nor angle at circumference, because you can see, for example, in this question the theta is just the intersection between two chords. For example, you can see here, but you can see the intersection between two chords will make you two arcs. For example, you can see x and y there. So you have a very special thing is that if you have such a result, then the theta will becomes half of x plus y. That means that you add x and y together and then over 2. So this one you can easily prove it. Why? Because you can just easily to add the line here. For example, you add the line here, so you can see these two line or these two chord will make you an angle here. As we mentioned, this angle should be 1/2x, as just seen in the second figure. So if you can't remember, so you take a look again. So this one 1/2x, so you can see that x will subtend 1/2x at the circumference. So on the other hand, you can see that this line will share with y also. Okay, so I should write better, sorry. So this one, yeah, so you can see it now. I can also combine the line you just drawn with this one, then you can have this one is 1/2y. So because these two angle, okay, using the second figure you have such a result, then you can easily see that for the theta, it's just the exterior angle from this triangle. And the theta is simply to add them together. So you have the result 1/2x plus y. So this one is very okay, it may be very useful for you to do some of the core questions, okay, if you can notice a very important thing here. So do remember why you have such a result, because you just add the line here. So I just want to show you the original figure once again. So do remember, okay, I'm just showing you the proof, but originally the figure, please wait a moment, yeah, should be in this way, yeah, should be in this way. So we say the theta should be 1/2x plus y if I say in radian measure. And now the proof, I just want to show you once again, okay, by redo it once again to let you see, yeah, it should be like this. Okay, so this is the exterior angle triangle, so you get the theta becomes this. Okay, so you may try to see, okay, what is the answer, okay, of the fourth figure. If this time, okay, the line is going outside circle to make the figure something like this, but when you make two lines outside circle, you still have two arcs formed. For example, you can see x and y here, and surely you can see x is greater. Okay, how can you represent this angle in terms of x, y in radian measure? So I'll give you this one as a bonus question. If you can answer me, I may add your bonus mark. Okay, no matter you are in 4C or even in other classes, just like 4E. Okay, so even you haven't, okay, taken M2 lesson. Okay, you haven't taken any M2 lessons, you may try to see whether you can write something about this figure. I will give it a prize. Okay, so this is the end of today's lesson. So I just give you the summary again. So do remember is that for the last session is very easy. What you need to do is just you have to understand the very important thing is that for equal relation, okay, it based from the, okay, congruent triangle SSS SAS. So all the things will becomes equal, including the arc, angles, and chords. But for the what? But for the, okay, but for the proportional relation, okay, we were talking about how large is the angle is corresponding is how long is the arc length. So we will say that they are in proportion, angle and arc. But do remember is that this one would only work for angles and arcs, but not for chords, because chords, okay, are not related to angle, okay, are not related to angle, but it relates to the triangle form from the circle. But actually how the triangle makes will be investigated later, but the most important thing is that the angle and the cost in general are not proportional. So you have to understand the very important thing is that this proportional relation only works on angle and arcs only. Okay, so this is a summary. So thank you very much. See you all in next week. Goodbye.